Hello. The following example is example 4.2.3 from your notes. We want to graph f of x equals 2 to the x power, and we want to give the domain and range. This is actually an exponential function. The reason it's an exponential function is because the exponent is where the variable is. I want to do a bit of a review real quick about what this means. Exponential functions are functions that are written in the form f of x equals b to the x power, where b is the base. There are a couple of conditions on b. The first is that b must be greater than 0. Also, b cannot equal 1. The reason b must be greater than 0, well, first of all, let's think about b being negative. If b was negative, -1, let's just say it was -1. -1 to the 1/2 power. Well, a 1/2 power means the square root of -1. So the square root of -1 would give me I. So any negative b value will give you a whole bunch of holes in the graph, because everywhere you have a rational exponent that is even in the denominator, that will mean that you have a hole in the graph. We also cannot use 0. The reason we can't use 0 is because 0 to any power, yes, that's 0, except for 0, because 0 to the 0 is undefined. Therefore, we can't use 0 there either, because you would have a hole in the graph. Also, we don't want to use 1. The reason we don't want to use 1 is because 1 to the x is always 1. So really what we would have is f of x equals 1. And if we have f of x equals 1, why do we want to write it as f of x equals 1 to the x power? Second of all, let's talk about an asymptote. This always has a horizontal asymptote. So the horizontal asymptote, all horizontal lines are written in the form of y equals a number. In this case, it's going to be 0. Unless you have some other value out here that's not in the exponent, it's always going to be y equals 0. If you did have 1, whatever you had out here is actually going to be your horizontal asymptote. Now let's talk about the domain. As long as you have a valid base, your domain is always going to be -infinity to infinity. Your range for this parent function is always going to be 0 to infinity, excluding the 0. And the reason why is because any valid base to any exponent will always be a positive value, which means it will never actually reach 0. Now then, there will always be 3 key points that you're going to want to know. Now, the 3 key points deal with the x values first. For the x values, you get a -1, a 0, and a 1. Well, the question is, what is f of -1 in this case? Well, b to the -1, anytime you have a -1 as an exponent, that means inverse. So the inverse of b is actually 1 over b. B to 0, that's the second one, well, b to the 0, as long as it's a valid base, is 1 every time. Also, your third point, 1, what's b to the first power? Good, b. At least I hope you said b. So there you go. Those are the 3 key points for the exponential function. You don't necessarily need to memorize them, but you do need to know how to get them. Okay, that's enough about exponents. Let's actually graph this. What I want to do is I want to create an xy table. Notice that this is actually its own parent function, because 2 to the x power is the simplest form. Notice the base here is 2. Our x values will always be -1, 0, and 1, and there will always be a 1 right there. It's these other two values that are going to change. The x value, -1, so 2 to the -1 means the inverse of your base. The base is 2, so the inverse of 2 is 1/2. For the 1, 2 to the first power, 2 to the first power is 2. In other words, you keep the base. Flip it for a -1, keep it for the 1. Remember, you have a horizontal asymptote of y equals 0. And yes, I do require you to draw the horizontal asymptote. Please be sure to label it as well. Now I want to graph these points. -1, +1/2. Now I'm assuming that each tick mark here is 1. 0, 1, and 1, 2. Now this can be a little bit difficult to figure this out. But once you know what the graph should look like, it should actually be easy. Notice what's happening here is that if I'm going to the right one place, I'm actually multiplying my y value by 2. That's what it says to do here, multiply by 2. So 1/2 times 2 is 1. 1 times 2 is 2. So at 2, doubling that 2 gives me 4. And at 3, doubling that 2 gives me 8. Now the reverse happens as well. If you're going to the left, you actually divide by 2. Or in other words, you multiply by 1/2. So 2 divided by 2 was 1. 1 divided by 2 was, well, 1/2. 1/2, a half of a half is 1/4. So at -2, that would give me 1/4. -3 would be -1/8. I hope you're seeing why, as you're going to the left, you're going to approach 0, but you're never actually going to reach it. That's why it's a horizontal asymptote. And then you just kind of draw what you have here. Do it as carefully as possible. And do it kind of with a curve. And there you go. That is the exponential curve. Now the domain is going to be all real numbers because it is always all real numbers. And this range, according to this, it's starting at 0 and going up. So it starts at 0, goes up, means it's 0 to infinity.